Hello, dear students. Let's see this question of IIT-JEE 2009. The question states, photoelectric effect experiments are performed using three different metal plates P, Q, and R having work functions. Phi P is equal to 2.0 electron volt, Phi Q is equal to 2.5 electron volt, and Phi R is equal to 3.0 electron volt. A light beam containing wavelengths of 550 nanometer, 450 nanometer, and 350 nanometer with equal intensities illuminate each of the plate. Which of the correct IV graph for the experiment is? This is a straight objective question. There is only one option correct, and we'll see which of the four options is correct. So as given in the question, there are three plates PQR with the work function 2 electron volt, 2.5 electron volt, and 3.5 electron volt. A light beam having three components wavelengths 550 nanometer, 450 nanometer, and 350 nanometer. This light beam is incident in each of the three plates. Whether the one of the component will be able to cause photoelectric effect or not, that will depend on if the energy of a photon of a light is greater than equal to the work function, then photoelectric effect will occur. So we will have to find the energy of a photon of a light, and the energy of a photon of light is hc by lambda. Value of hc is 1240 electron volt nanometer, and divide by if lambda is in nanometer, so immediately this 1240 and lambda will give me the energy of a photon in electron volt. So let's try to find the energy of each photon of the three components of the light beam. So for the component of wavelength 550 nanometer, energy is 1240 divided by 550, and that will come out to be 2.25 electron volt. And energy of a photon of wavelength 450 nanometer will be 1240 divided by 450, and that would be 2.75 electron volt. And energy of a photon of light of wavelength 350 nanometer would be 1240 divided by 350, and that will come out to be 3.54 electron volt. So for which of these components photoelectric effect will take place for each of the plates? For the plate P, all the lights, all the components of the light have a greater energy compared to its wavelength, its work function. So all these three components will be able to cause photoelectric effect. For the plate Q, its work function is 2.5, and these are the energy of the photons, and the photon having wavelength 450 and 350 have a greater energy compared to its work function. So these photons will be able to cause photoelectric effect. And the plate R, only one wavelength 350 nanometer has a energy greater than its work function. So only this wavelength will cause, this component of the light will cause a photoelectric effect. And then we also want to find the stopping potential in each of the three cases. So stopping potential is the maximum kinetic energy of the emitted photoelectron divided by E. And the maximum kinetic energy is the energy of a photon minus work function. But we have three types of photons. So out of those three photons, we will take the maximum energy of the photon. So again, here that will be E max for a single photon minus work function, and then divide by E. And the maximum energy of the photon is of the photon of wavelength 350 nanometer. So here, so for the plate P, stopping potential will be 3.54 minus 2 divided by E. So that would be 1.54 volt. For the plate Q, stopping potential would be 3.54 minus 2.5 by E. So that would be 1.04 volt. And for the plate R, work function, stopping potential would be simply 0.04 volt. So we got the stopping potential for all the three plates. And then we also want the maximum photocurrent. See, the maximum photocurrent will be for that plate in which the maximum number of photoelectrons are emitting. The maximum number of photoelectrons are emitting. See, all the three wavelengths had the same intensity. So the number of photon incident on all the three plates are the same. But in plate, all the three color of light are causing photoelectric effect. In the plate 2, only 2 lights are causing photoelectric effect. And in plate R, only 1 light is causing photoelectric effect. So here IP max would be IP max. For the IP max, this will rank 1 and this will rank 2 and this will rank 3. Now let's look to the graph. For the graph, there are two information that we'll be looking to, that on this axis, on the left side of that origin, there will be a stopping potential. So we'll look that for which plate the stopping potential is more, and on here the current has got saturated. So we'll see that for which plate there is a maximum current or the maximum saturation current. So according to our data that we got, the plate P has the maximum stopping potential, and the plate P has also got the maximum saturation current, and plate R has got the least stopping potential, and so is the least maximum current. So on these three parameters, you can see that here this is for the plate P, this is for the plate Q, this is for the plate R. These are the stopping potential. Maximum stopping potential is for the plate P, and then for Q, then R. And this is the maximum photocurrent, that is also for P, and then for Q, then for R. So our correct answer is option A. Thank you.